Okay, ladies and gentlemen, I'm going to go over some motion questions with trig functions. And what you're going to see here is the first, I should say, it's kind of bread and butter mass on a string that vibrates horizontally. So let me see what's happening here. Okay, sorry about that. Having weird glitches with this iPad. So bear with me. So the string and the mass, I should say, is vibrating horizontally. So what they gave you here was a position function given by x of t is 6 cosine t. So I guess x is measured in centimeters and t is measured in seconds. So just to kind of give you a quick little understanding here of what they mean with x being a position function, horizontal motion, they'll typically use the x-axis from algebra, the real number line. And the mass that we looked at in class with these examples is vibrating horizontally back and forth indefinitely. It's called simple harmonic motion. So if a mass is moving, I guess we'll draw some of the pictures if we can. Right? You got the string. Here's your mass, maybe at equilibrium. Okay, and they're gonna start the motion of this in theory forever, vibrating back and forth. Okay, assuming no resistance. I won't go into all the details of the physics behind it, but essentially this string or the mass is just moving back and forth by the cosine curve. Okay, so they want us to determine in the first part the velocity function. Now, velocity is the first derivative of your position function. So this is in some ways the dx dt. I'll use operator notation. So if they want that velocity function, just differentiate the position function, which is 6 cosine t. So we say 6 cosine t. This will give us velocity. Now, if you want to write it as v of t, like we've been doing, you can do that. Now, pull out your constant 6, differentiate cosine, and so the derivative of cosine is minus sine, so you get minus 6 sine t. So here's your velocity function. Okay. Pretty good. I'm going to wake up some other apps here. Okay. So we did the job by getting velocity. Okay. Now, if they say to you, hey, now in question B, so we got velocity, what's the acceleration now? All right. Acceleration function is the second derivative. Or we should say acceleration is the derivative with respect to time of your velocity. And so I have to differentiate the negative sign, negative 6 sine t. Pull out my constant there, your constant, and differentiate sine. And the derivative of sine is actually cosine. So this is going to be simply negative 6 cosine t. You have acceleration now. All right, now I think we need more paper here. We're going to add a page. All right. So we've done the first part, getting a velocity function and an acceleration function. And now notice what they're saying here. To determine the position, velocity, and acceleration of the mass when your time is actually 2 pi over 3 seconds. 2 pi over 3. All right. So in this question C, if I just label everything, I'll say here's my A. Here's my B. Question C is essentially asking for the position when my time is 2 pi over 3. Velocity when the time is 2 pi over 3. Acceleration when your time is 2 pi over 3. So question C, they're just asking for those kind of things. So, all right. So I guess I'm going to, well, let's write down what the position function is. It's x of t is 6 cosine t. So I'm going to plug in t being 2 pi over 3 here, right? So make sure t becomes 2 pi over 3. I'm just going to plug that in so you guys can see that. X of 2 pi over 3 is 6 cosine 2 pi over 3. Okay. So essentially what I need to know is what is cosine of 2 pi over 3? And there's various ways for you to find out what that value is. You may think, for example, pi over 3, by the way, is 60 degrees. So this is really trying to ask you the question, what is cosine 120 degrees? Now, I can go over all the details. Like I did in class. You know, how do we derive cosine 120? There's various ways to do that. I don't know, maybe we should think of all students take calculus if we really want to go through the detail. Part 1, quadrant 1, 2, and 3. Right, quadrant 4. So 120 degrees is actually in quadrant 2. So if some of you guys remember, I'm going to use a highlighter here. 120 is in quadrant 2. And, I'm just going to go through a little bit of the trig. All students take calculus. And we put the T inside here. And all students take calculus. Okay. So if you guys remember this acronym of all students take calculus, what that means is it tells you the quadrants where really 3 in all the trig functions you could deduce the sign. And so in quadrant 2 with 120 degrees now, sign is positive. That's why we have the S for quadrant 2, which implies cosine's negative. So what we know here is that cosine will be negative here, essentially. Cosine of negative 120, I guess I'll write it up here, is a negative value. However, we got to think about, for the 120 degrees here, we got to think of the reference angle. The angle there from the ray to the x-axis, if this is 120, this will be 60 degrees. So essentially, the reference angle that you'll have to use here, which is located right here, would be cosine of 60. So if you really wanted to dive into the weeds with all of this, go to your special triangle, if I can draw one. If you guys recall, 60 degrees, 60 degrees, 60 degrees. Remember some definitions here. There's a few ways to do this. 2, 1, square root of 3. The definition of cosine is adjacent over hypotenuse. Now that's cosine of 60, but we're trying to find cosine of 120. All that'll be is negative 1/2. Now, okay, so if you said to me, hey, I just want to use technology, I'm going to use my calculator. Can I do that? Well, I guess you can. Make sure this is in the proper mode. If I'm thinking degrees, I could do this in radians. It's not a problem. Let's check the mode here. Okay, we'll check the mode of our calculator. So we go to second. We'll check the mode there. We're in degrees. I can change it to radians. Excuse me. And I don't know, we'll keep it there. So you say, well, what are you talking about? Cosine 120 degrees is negative 1/2, like we just deduced. So, I mean, we could use the calculator, I guess. Now, what that means here is if this is negative 1/2, the position at 2 pi over 3 is 6 times negative 1/2, or simply negative 3. Now, that's in centimeters here. So, we got another answer that's important to get. It's negative 3 centimeters. So you guys can see that. So they want to know the position, the velocity, and acceleration at that time. So, all right, that's the position. If you want the velocity at that time, you use the velocity function, and you're going to plug in the 2 pi over 3. So, what's your velocity at that time? So here's going to be our velocity. So we say v of 2 pi over 3 will be now negative 6, I think. Yes, negative 6 sine of 2 pi over 3. So we need to know the value of sine of 2 pi over 3 now. So, well, I guess if you said I got my calculator out, sine of 120 is this numerical value, 0.866 approximately. Okay, well, go back to your special triangle. Remember your definition of sine. So if I'm going to look at 60 degrees, sine is opposite over hypotenuse. Cosine is adjacent. So if I change the color, cosine was adjacent over hypotenuse. It was the 1/2. But this is for the reference angle. What we know for 120, it's in quadrant 2. That means sine's positive. So this is going to be the square root of 3 over 2. And I want to kind of illustrate that to people just in case they need a review. That the square root of 3 here divided by 2 here is in fact what we're talking about. So I want you guys to see that. Now, if I change my mode to radians and I wanted to find these values here, we'll start with cosine. We can say 2, and we got to find pi. It's here in blue. 2 pi over 3. This is in radian measure. Hold on. Yeah. Uh-oh. What happened here? Let's go to mode. We didn't change it to radian. That's what happened. Okay, we just changed it to radian here. Okay. So, do it again. Cosine 2, here's our pi, divided by 3. So there we go, ladies and gentlemen. You're going to get the negative 1/2. Sine 2 pi divided by 3, you're going to get the square root of 3 over 2. So your calculator gets these answers. Make sure it's in the right mode if you're going to use it, okay? You could even use your brain because some of these questions are very specially chosen, like this one. And we end up saying that the velocity at 2 pi over 3 here is negative 3 square root of 3. That would be centimeters per second, okay? So just going over some little details, and the devil's in the details, but I think they're very helpful. Now, I want you guys to note that the particle, since it has negative velocity, is moving in what we call the negative direction. So you're moving, the particle is moving in the negative direction. Sure, it starts at -3. So you say, what do you mean by that? Well, going back to that picture over here, if I erase, and this is kind of the weird thing I was having earlier, it doesn't let me stick with the eraser. Maybe I'm touching something in the iPad. Maybe this is, anyway, I didn't want to erase the line. So let me do this here at least. If 0's here, your particle is starting at -3. Okay, that's the position function. We should say the negative direction on x-axis is to the left. Positive directions to the right. So the point I'm making is when t is this location here, right? I mean, particle's not, let me take it back. Your particle's not your particle is not starting at -3. It is at -3 though, when your time is 2 pi over 3. The particle starts when t is 0. So if I plug in 0 here, okay, 6 cosine 0, cosine of 0 is 1. So the particle is actually started at 6. So you guys know, somewhere over here, I guess. And that happens when t is 0. I'm just going over the details here. All right, so it looks like the particle is moving in that direction at least, okay, at -3. So we're plotting the point, or the mass, we should say. Let's find acceleration now, because that's what they're asking. Acceleration at that particular time. So a of t now. A of 2 pi over 3 will be, if I plug in 2 pi over 3 now for the acceleration, is -6 cosine t. So it's -6 cosine 2 pi over 3. Now, to say this to you, we already found cosine 2 pi over 3. It's -1/2, right? So this is what we already determined, -1/2. So I can use that and say, hey, you are -1/2. And now the acceleration at that time, 2 pi over 3 will be -6 times -1/2, which is +3. So let's actually keep the units here. Centimeters per second squared. So you got your acceleration, ladies and gentlemen. All right. So I want to point out something here. The particle is being pulled in the positive direction. Because of the fact that your acceleration is positive, what we say, it's being pulled or pushed in the positive direction. Positive direction is to the right. Okay, and like over here, particle is moving in the negative direction, but it is being pulled in the opposite direction. Okay, now that's going to mean something, and I think I might have asked the question. Question D. Determine if the mass is either speeding up or slowing down at that time. Now, because remember what we discussed. Speeding up is when velocity and acceleration have the same sign. Slowing down is when they have opposite signs. So since the velocity is negative, moving in the negative direction, but it's being pulled in the positive direction to the right. For question D, the particle is slowing down. When t is 2 pi over 3. So at that instant, the particle is simply slowing down. Okay, it might be moving in one direction, but it's being pulled in the other. So that slows you down. So, ladies and gentlemen, that's how we use calculus. Okay, E. At what time t does the mass stop? Oh my gosh. At what time t? For what t does the mass stop and really change direction? Well, you guys remember the mass stops when the velocity is 0. And then they restricted the domain because this goes on forever. It's simple harmonic motion. So they say, hey, just look at the time between 0 and 2 pi. So the last question, E, they really want to know for what time t is velocity 0. So we want the velocity function again. So we need velocity. And the velocity function is found over here. It's negative 6 sine t. So negative 6 sine t. There's your velocity. You set that equal to 0 and solve for t. And the domain is restricted. So 0 to 2 pi. Okay, that's convenient. Now, negative 6 sine t, if we divide both sides by negative 6, we'll get sine t is 0 here. So the question is, where is sine t 0 for the interval 0 to 2 pi? Now, again, what you will always see, I should say, or you should know, that your sine curve, ladies and gentlemen, the graph of the sine curve, there's various ways to do this. I discussed this in class, but this actually shows up quite often in STEM classes. We want to know, this is 3 pi over 2. Essentially, where sine is 0 now. So look at the sine curve. Okay, I'm going to sketch a sine curve here for us. Sine being 0 is another way of asking where are the intercepts, and in this case, it's time intercepts, t. So that happens when t is 0, when t is pi, and when t is 2 pi. So they're asking for the intercepts of sine. These are the values when, I should say, the particle has stopped. T is 0, t is pi, t is 2 pi. This is where the velocity of the particle is 0. But they want to know, essentially, this. When they ask you acceleration, at what time t does the mass stop? Okay, we answered that part. And changes direction. It will because it's oscillating over this interval. So here's the answer for E. Particle stops for these values of time. Okay? All right. Interesting kind of question. I just wanted to remark, if you were to plug these values into the acceleration function, okay, that tells you whether you have a push or a pull. So even though the particle is stopped, I'm going to call this a note here. If I bring this down, because sometimes they want to ask you that question, what's the acceleration? So I'm going to give you guys another, let's add another sheet here. I want to give you guys a note here. They want to know at times the push and pull part. So note, they can ask, what's the acceleration when the mass or particle stops? And we know it stops at these times. T is 0, T is pi, and T is 2 pi. So we know that already. So let's find the acceleration for these values. They didn't ask that in the question, but it is popular to ask this. And I'll show you why. So at 0, what is cosine of 0? That is 1. So your acceleration at 0 will be negative 6 times 1. Or we say your acceleration at 0 is simply negative 6 centimeters per second squared here. Now, why is this a popular question? It's popular because your acceleration is negative. That means it's being pulled in the negative direction. And in this case, pulled to the left. Yes, because it's negative. You're pulled to the left. So even though the particle is stopped at that time, it's being pulled to the left. So that kind of explains here, if you go to this picture now, sort of what you see. The particle is starting at 6. It's being pulled. It's stopped at this point, but it's being pulled to the left, acceleration. Okay? That's the pull. I guess I don't know what color to use for acceleration, but whatever. So it makes some sense. In fact, we know that it stopped at pi. So even though it's pulled to the left, I can start to safely say, guess what? Your particle's moving in that direction, and I'll leave the pull in black. So I'm just going to say, hey, it's being pulled in the direction toward negative 3, you guys know. So that's kind of the idea here. It's being pulled in that direction. Okay. And that's why it's very popular to ask these kind of questions. Hey, what's the acceleration at these points? What's the acceleration when the particle stops? So you can see where it's being pulled, because acceleration is a push or a pull. So, you could check all those time values. You're going to get cosine in this case here. If we said, what about at pi? Because the particle stops at pi. Well, you can just answer now, acceleration at pi is the negative 6 cosine pi. Cosine of pi now we know is negative 1. Think of the graph. That helps me. Negative times negative is going to be a what? Positive, and that's centimeters per second squared. So here's your acceleration. It's positive, so you're going to be pulled to the right. Positive acceleration. Say, okay, what about at 2 pi? Well, plug in 2 pi now. So you get your acceleration going to be negative 6 cosine 2 pi. Well, cosine 2 pi is 1. So at 2 pi, we get negative 6 times 1. Your acceleration at 2 pi will be negative 6 centimeters per what? Second squared. And there you go. So at 2 pi, the particle is being pulled to the left. And they say push or pull, but whatever. Pulled to the left. That's the 8th grade definition of acceleration. So push or pull. Or I should take it back, force. But force is mass times acceleration. So it's kind of an interesting kind of idea where it's mass times acceleration. Okay. They never ask these questions, but I'm giving you the details because they're important. Now, number 2 is a little different. Let's see, number 2 is very similar to number 1, but you're going to use chain rule, I guess. Let's look at number 3. Guess we can do that. Let's look at number 2 just to compare and contrast. I think I want to try that out. I wasn't planning on doing it, but I am. I'm going to add a couple of pages here. Now that we've known what to do in great detail for number 1, we'll try number 2 here now. Okay, we're given another horizontal movement, mass on a spring, mass on a string. But this time, the motion is given by, or I should say the position is given by x is 4 sine pi of t. So the first question, hey, A, what's the velocity? B, what's the acceleration? All right, you guys know what we got to do. Let's do that. Okay, so again, my velocity is the derivative of that position function. This is also x prime of t, by the way. So let's differentiate now for sine pi t. So this will be 4 derivative of sine pi. Well, the derivative of sine is cosine pi t, but do not forget the chain rule, because this is chain rule. Don't forget the chain. So this is pi. So we end up with 4 pi cosine pi t, and this is my velocity function. Okay, it involved chain rule. So I want to compare and contrast. Sometimes they'll give you a question that has chain rule. This is why you study how to differentiate with chain rule. So now we got the velocity function. And again, sometimes they write this as x prime t. Okay, that's velocity as well, because you took the derivative of this x. So, and this is actually dx dt, so you guys can see that, but fine. Now B here. Acceleration is the derivative of velocity. So we say we're going to differentiate velocity now. Differentiate the 4 pi cosine pi t. Now pull out your constant here. What's the derivative of cosine pi t? It's minus sine pi t times, don't forget the chain rule. I'll write every step. Well, let me just put this since I'm out of space, and then this is weird. It's happening with the iPad. It doesn't stay on the eraser. So don't forget the chain. This is pi. There's a chain there. Maybe I need to do the detail. So let's differentiate pi t, chain rule, and you guys know this will be pi. So everything all together, don't forget we have other terms. Acceleration is going to be negative 4 pi squared sine pi t. So don't forget the 4 pi, the negative sine pi t, pi. There we go, ladies and gentlemen. Here's your acceleration function. All right. They now want us to determine position, velocity, and acceleration when time is 1/4 of a second. So in question C, this is AB, 1/4 of a second now. X of 1/4, V of 1/4, A of 1/4. That's what they want. So plug in now 1/4 for T. Okay, so we get x of 1/4. I guess that's C. Is, well, what's the position again? 4 sine pi t. And what we get now is 4 sine pi over 4. Now, that's 45 degrees, ladies and gentlemen. So there's a couple of ways. Again, you say, well, what is sine of 45 degrees? Well, you could go to your special triangle here, 45, 45, 90. And remember the definition of sine. Okay, sine is defined to be O opposite over hypotenuse, and then that simplifies to, or rationalize the denominator, you get square root of 2 over 2. So, if you take a trig course, you probably have that memorized. So we take 4 times the square root of 2 over 2, and then the position at 1/4 is 2 square root of 2, and that's in centimeters again. So, ladies and gentlemen, there you go. There's your position function. We need velocity now. Via 1/4, go to the velocity function, 4 pi cosine pi t. Well, t is 1/4. So 4 pi cosine pi over 4. And again, using the same special triangle, that's the square root of 2 over 2. So some of you guys may know that. 2 pi square root of 2 centimeters per second. This here is the velocity now. Okay. Acceleration. Acceleration at 1/4. Acceleration is negative 4 pi squared sine pi t. So negative 4 pi squared sine pi times 1/4. 1/4 pi, 45 degrees, square root of 2 over 2. So we can answer this question. Negative 4 pi squared times the square root of 2 over 2. So my acceleration when t is 1/4 is negative 2 pi squared square root of 2 centimeters per second squared. Okay. Plugging in the values. So this is question C, and then question D. Determine if the mass is speeding up or slowing down. Speeding up or slowing down at this time. Well, let's check velocity and acceleration. Velocity is positive, so you're moving to the right. Acceleration is negative, so you're being pulled to the left. I'll put L. So the answer to that question, I guess that's D, is you are slowing down when t is 1/4 of a second. Slowing down. All right. Part E now. At what time t does the mass stop and change direction? The mass stops when velocity is 0. So velocity needs to equal 0 for the mass to stop. So we got to go to the velocity function, 4 pi cosine pi t. So we set 4 pi cosine pi t, that equals 0. If we divide both sides now by 4 pi, we can say this means cosine pi t equals 0. Now, I wanted to talk about this because this, again, goes back to if you took a trig course and studied how to solve some trig equations. That is important. You don't want to skip those kind of things. And so let me describe this to you guys the way I look at it. And I think they restricted the domain for time to be from 0 to 2 pi. Yeah. See that? 0 to 2 pi. All righty. So we're going to factor that in. So what I say to people is this. You're going to do a substitution here. You let theta be pi t. So you're trying to solve where cosine of theta equals 0. Now, remember what I said earlier. These curves show up a lot in STEM, so it's good for you to know what they look like. So you could start at 0, you go to pi, you go to 2 pi, in the middle here is pi over 2, 3 pi over 2, you start at 1, you end at -1. So your curve really, and I want to be a little bit more to scale. Oh, whatever. Let's move that down here. I'm getting to the minimum. Here we go. So they're pretty much asking, where is your cosine equal to 0? They're asking for the intercepts. And that's not a t. This is theta here. So this happens when my time is pi over 2 or my time is 3 pi over 2. So when I teach a trig class, I make sure they look at this particular detail. It's very important. Now, we know theta really is pi t. So how does that work here? And again, I apologize. Let's get this out here. These are thetas. Theta's pi over 2. Theta's 3 pi over 2. Let me apologize for that. Since theta is pi t, what you now do is you say, theta's pi t. You're changing your variables back. So this means pi t is pi over 2. And it means pi t is actually 3 pi over 2. Okay, now notice theta is over these intervals. Now, there's a little bit more detail here. Alrighty. So you might say, well, what do you mean by the detail? Let's dive into the weeds again and go to our all students take calculus here. Region 1, Region 2, Region 3. So we have all students take calculus. Well, maybe we don't even need that. Yeah, we don't need that. Sorry. All right, we don't need that. Let's see what t is. If we solve for t will be 1/2, or t will be 3/2. Okay? So, all right, there's 2 time intervals. Now, I'm going to change this on you guys just a little bit, and I apologize. This is kind of a typo. But when I originally took this from another book, they put 0 to 2. Okay, and we're going to keep that 0 to 2. So I'm going to fix that, but whatever, 0 to 2. Now, that makes a lot of sense because notice your time here is 1/2 and 3/2. This is your time values for question E. So let's remove that. We'll do 0 to 2. And then that's the end of the question. We're good. I can actually say to you, note, what if you said, but, I want 0 to 2 pi. That's about 6 point something here. Go back to these kind of solutions for cosine. Yeah, I guess we could do that. Pi over 2 plus. Yeah, so go back to the picture I started to do. All students take calculus. If I can do this. It's kind of weird how it does this. Okay. So let me remind you guys, all students take calculus, although you're really not going to use that. Pi over 2, if you guys recall, is right here. Okay, there's pi over 2. That's the first solution. The second solution is actually 3 pi over 2. So if I said to you guys here, right, we're going to look at this theta idea, cosine. Notice this. We can say the general solution here, since we're not using all students take calculus because the angle is on the axis there, it's not off the axis. So even if you said, I want to see that, there you go. But we're going to add a multiple of n pi now because of the fact that in general, this is 180. This is pi, and we can generally get our solutions this way. Theta is pi over 2 plus n pi. That's your general solution. So if you went back now and said, hey, but theta is pi t, do that. Theta is pi t. So what that means is pi t equals pi over 2 plus n pi. N is an integer. We need more paper. And what you'll see now is if I divide everything by pi, you get t is 1/2 plus n. So that'll give you, I should say, a way to get all your time values. Because now, if you said, you said there's kind of a typo, and originally you said 0 to 2 pi. Pi is about 3.14. So this is about saying this is like 6 or something, right? Well, you can generate your solutions here by changing the value of n, because n is an integer. And you can actually now get the other values because you have a formula for that. Integers look like this. However, you might say, but we can't have negative time. Yes. So the values of n you're going to use will be these values. So it's really whole numbers. So n is 0, t is 1/2. Let's see how to use this. This is a trig thing. So again, trigonometry shows up. N is 1. T is 1/2 plus 1. 3/2. N is 2. 1/2 plus 2. 5/2. That's 2.5. N is 3. 1/2 plus 3. 7/2. 3.5. N is 4. 1/2 plus 4. 9/2. You guys, 4.5. And so on. But this is how we use the ideas from trig, ladies and gentlemen, in calculus. 11/2, 5.5, and that's going to be probably it. But this is the time values in the interval. If we stuck from 0 to 2 pi, you essentially have more values of t there because this is about, pi is about 3.14, right? So it's approximately 6. I just want to be clear here about the issue. Pretty good stuff, though. Pretty good stuff, pretty deep. It involves really trigonometry, and that's why it's a prerequisite, because these functions don't just go away because you didn't take trig, right? All right, let's try question 3. The equation of motion given for a particle is measured this way. Okay, this is another good kind of question. Notice they want they're giving you a position function again, but they want what? Velocity and acceleration. Let's try to find that out, okay? Velocity is the derivative of that position function. So the derivative of sine is what? Cosine pi over 6t. Don't forget the chain pi over 6t. Derivative of cosine will be minus sine pi over 6t. And then don't forget that chain too. I'll put it down here, times the derivative with respect to t pi over 6t. So this is chain rule, and we get pi over 6 for the chain, pi over 6. Okay, so here we go. Your velocity function is pi over 6 cosine pi over 6t minus pi over 6 sine pi over 6t. So there's your velocity function. So this is what they want. Acceleration function. It's derivative of velocity, right? So you're going to have to put pi over 6 cosine pi over 6t pi over 6 sine pi over 6t. Derivative of a sum is sum of derivatives. Pull out your constants. Let's get this out here. Okay, so let's do these derivatives now. I'm going to say derivative of cosine minus sine pi over 6t times your chain. I'm going to just say pi over 6. By now, you guys should be good with that. Derivative of sine is cosine pi over 6t times the pi over 6. So here's your acceleration. If we look at every detail here, pi over 6, pi over 6, there we go. Cosine, we got it all here. So here we go. Pi squared over 36. And that's going to be negative. Sine pi over 6t. Plus pi squared over 36 cosine pi over 6t. So ladies and gentlemen, here you go. And there it is. All right. Okay. Determine the acceleration when t is 1 second. So this is a of 1. A of 1 now. So a of 1, we say, what's our acceleration when t is 1 second? So let t be 1. That's what they're asking. Sine pi over 6 times 1 plus pi squared over 36 cosine pi over 6 times 1. So we get minus pi squared over 36 sine pi over 6 plus pi squared over 36 cosine pi over 6. Let's write that down a little better. 180 divided by 6 is 30 degrees. So I just want to mention this to people. 30 degrees here. 30 degrees. So sine and cosine of 30 degrees. My special triangle. So let's look at this special triangle here. But now, right in here, 30 degrees, we bisect the 60. So what we can say now is sine that 30 degrees becomes, definition of sine, opposite over hypotenuse. Cosine 30 degrees is going to be adjacent over hypotenuse. So replace this number here with 1/2. And replace this number here with a square root of 3 over 2. So your acceleration at 1 second now negative pi squared over 36 times 1/2 plus pi squared over 36 times the square root of 3 over 2. So you might look in back of the book and find negative pi squared over 72 plus the square root of 3 pi squared over 72. So we're going to factor out pi squared over 72. You get the square root of 3 minus 1 now. Let's add a page. All right. And by the way, I think this number is positive because the square root of 3 is bigger than 1. So this particle is being pulled to the right, positive direction. Okay, pulled to the right. Ooh, the dreaded acceleration when my velocity is 0. Ooh, another trig equation to solve. V is 0. And by the way, look at question D. Just remember where the particle is speeding up or slowing down at 1 second. So we need V of 1. I'm just going to answer that last question first. I just want to note because that's going to be the next question. We're going to find let's just note here. V of 1 now is pi over 6. We're going to let t be 1. See what we get. Pi over 6 cosine pi over 6. And I think that's minus, right? Pi over 6 sine pi over 6. Yeah. Minus pi over 6 sine pi over 6. 30 degrees. Cosine of 30 degrees, we said, was square root of 3 over 2. Sine of 30, 1/2. Okay, let's factor out pi over 12, and you get square root of 3 minus 1. That's positive, just so you guys know. So the particle is moving to the right. And so the speeding up question. Okay, the speeding up question is going to be this. Particle is speeding up. You say why? Because your acceleration is positive. It's moving to the right. It's being pulled to the right. Velocity is positive. It's moving to the right. So therefore, the particle is speeding up when t, the value of t is going to be, what was t again? 1 second. That's right. Okay. Good news. Good news. Good. All right. Now, so we answered that question. We answered D before we did C. So if I had to fix some typos, I'd switch those. Okay. So determine whether the particle is actually slowing down or speeding up. We answered that. Now, the stop question. The stop question again is going to be a trig question, and I'm not sure which one that was, but particle stops, right? When velocity is 0. So I got to go to the velocity function here. Where is that? V of t now is pi over 6 cosine pi over 6t minus pi over 6 sine pi over 6. So my velocity function, you get pi over 6 cosine pi over 6t minus pi over 6 sine pi over 6t. And that velocity is 0. So you say pi over 6 cosine pi over 6t minus pi over 6 sine pi over 6t. And then that equals 0 now. Okay. Again, you're going to see pi over 6 cosine pi over 6t will equal pi over 6 sine pi over 6t by adding the sine of both sides. Divide both sides now by pi over 6. And you get the cosine equal sine, which implies, again, the very famous classical tangent pi over 6t is 1 now. And we need more paper. I'm trying to find where that particle stops. It's going to just be a trig equation. So at this point, we're going to do a substitution now. Right? You're going to let theta be pi over 6t. So you end up with tangent theta is positive 1. Now, if theta is going to be over the interval of 0 to 2 pi, right? Theta is pi over 4. Well, let's do the general solution again, because they're going to restrict the t domain. See if they gave you any restriction. No, they didn't. So you want to know, oh, no, they did. 0 to 2. Sorry. All right, 0 to 2 for t, not theta, though. 0 to 2 for t. So let's do the following. We're going to solve this trig equation. Let's go back to our all students take calculus. You can see maybe a little bit better in case you forgot. Okay, in case you forgot. Region 1, Region 2, Region 3, Region 4. And you say, all students take calculus. Now, again, tangent theta is 1 implies theta has to be in quadrant 1 at 45 degrees, pi over 4, and in quadrant 3, the opposite quadrant. So here's how you handle that, generally speaking. Remember, this difference by pi. So the general solution for theta is simply pi over 4 plus n pi, the general solution. Now, since theta here is pi over 6t, okay? Replace theta with pi over 6t. And what that gives you is pi over 6t will be pi over 4 plus n pi, okay? Multiply both sides by 6 over pi, I guess. So let me kind of do that there, sort of, so you guys can see this. And then now you end up with what? T equals 6 over pi times pi over 4 plus n pi. So t is going to be really 6/4 plus 6n. Remember, you're going to distribute that. So your t is actually 3/2 plus 6n, where n is an integer value, but all right. So you might say, but Mr. Judge, isn't t supposed to be from 0 to 2? Yes. Let's see how that works. So your particle stops, ladies and gentlemen. Let's see. Now, when n is 0, t is 3/2. When n is 1, t will be 3/2 plus 6. So 12/2. This is 15/2 now, 7.5 seconds. So the point is, this is your t, 3/2 seconds. So you did get the general solution here, and then you switched back to your variable. So this is a trig, ladies and gentlemen-ish question that comes back to solving trig equations. Anyway, number 4 is done very similarly. So you guys know. Now I'm going to try number 5. Should I try number 5? Well, this is now, okay, let's do 5 because it's now on a vertical. You got a mass spring vertically done now, up and down. So y. Now, y of t. So just to kind of show you guys, it doesn't matter if it's x or y. This is now vertically up and down. We could get a velocity function and acceleration. Let's do that here. So velocity here is the derivative of the position function, and I guess we should do it this way. It's dy dt, which is d dt of that position 6 sine 1/2 t, which is 6 d dt sine 1/2 t, and then the derivative of sine is cosine 1/2 t. Don't forget the chain times 1/2. So we get 6/2, which is 3 cosine 1/2 t. There's your velocity. Acceleration now is the change in velocity over time. So we're going to look at the derivative of 3 cosine 1/2 t, which will be 3 cosine. What's the derivative of cosine? We know it's minus sine. And then don't forget the chain times the 1/2. So we're going to get negative, looks like 3/2. Let's double check. 6, 3, 3/2. Yeah, cosine of 1/2 t. And that's minus sine. Oh, it's kind of late. Ah, I thought something was wrong. There you go. This is minus sine, ladies and gentlemen. Okay, kind of late. All right. That's what they want. Now, what else do they want? Show the speed. Well, speed is a maximum when acceleration is 0. Determine whether the particle is speeding up or slowing down. I'm going to actually do something here. I'm going to change question B. I'm going to clean that up for you guys. The speed is a maximum when acceleration is 0. So get the acceleration function. Okay, and set it equal to 0. How about if we just do it something like this? We're going to change that question here and say, how about when is the acceleration 0? How's that? When is your acceleration at 0? Means, okay, so set your acceleration equal to 0. So you get negative 3/2 sine 1/2 t equals 0 here, which means sine 1/2 t is 0. All right. All right. This is a nice, simple, and easy trig question, which means when is sine theta equal to 0, look at the sine curve. Theta is 0, theta is pi, theta is 2 pi. Okay? And actually, generally speaking, if you guys remember the general solution, theta is simply n pi, right? So this is a very classic trig equation that you're seeing here. A lot of these are fundamental classic. All right, now you say, okay, but what is theta? Theta is going to be, again, right in here, 1/2 t. So, since theta is 1/2 t, we're going to use that. Here you go, theta. You're really 1/2 t. So 1/2 t is actually n pi, which means t is 2n pi. All right. This is the time where your acceleration is actually 0. Now, what does that mean for acceleration to be 0? That means there's no push or pull. Okay? So it's no push or pull for these values of t. So if they gave a restricted domain from 0 to 2 pi now, I got to see if that should be changed too. Yeah, maybe. T is 0, right? Well, let's use n is 0. All right, maybe not. We'll just keep it that way. N is 0. When n is 0, t is 0. When n is 1, T is what? 2 pi. And that's it. Time is 0, time is 2 pi. At those times, you have 0 acceleration. So, all right, whatever. Let's go with that. Determine whether the particle is speeding up or slowing down when t is t pi seconds. Okay, so the speeding up, slowing down. So at this point, you guys may remember, all we got to do is check the signs for v of pi and a of pi, right? Because that's your time t. All right, so v and a. Here's my v, by the way. So just plug in pi here, plug in pi here. And here's a, plug in pi here, plug in pi over here. So I'm going to bring all this stuff down. Okay, so we can find out what that is. All right. V of pi is 3 cosine of pi over 2. Now, cosine pi over 2, if you guys remember, cosine of 90 degrees, well, that's 0. Is that right? I think it is. Cosine 90 is 0. All right, now you say, well, let me check my calculator then. Forgot what mode it's in. We could leave it in radians. That's fine. Cosine pi over 2, sure enough, is 0. Well, that's interesting because what that means is the velocity is 0 at pi over 2. You got 0 velocity. Acceleration at pi right here. It's actually minus 3/2 sine pi over 2. So I'm going to do that here. Minus 3/2 sine pi over 2. Sine of 90 degrees is 1. So your acceleration, ladies and gentlemen, is minus 3/2 times 1, or we're going to simply say this is negative 3/2. Now, this is going to be, I guess, centimeters per what? Second squared. This is 0 centimeters per second. So let's keep that there. Now, I want to point this detail out like I talked about earlier in class. Velocity of 0 means a particle has stopped. And it's being pulled to the left because acceleration is negative. So you have a particle stopped at that time and it's being pulled to the left. Now, does that mean the particle is speeding up or slowing down? Particle's not moving. Okay, because it's stopped. So this is kind of a trick question to ask you, hey, determine if the particle is slowing up or speeding down. It's not. It's doing neither. Neither. The particle simply stopped. So I don't know. Maybe I should add that kind of, situation in the worksheet. Is it neither? Because 0 doesn't have 0 is neither positive nor negative. Neither. But anyway, ladies and gentlemen, I think I'm going to stop here. The next one is actually very similar. So if I end up changing anything, which I probably won't, I'm just going to ask, I'll probably change this to, hey, when is acceleration equal 0? If I go back and do that, make a little change. All right. So I hope you guys enjoyed the video here, the demonstration. Just to show you that you can have this motion idea with trig functions as well. The world just doesn't exist with nice polynomials. Trig functions rule the world, ladies and gentlemen, because 90% of physical science is trigonometry. So You just need to make sure you get strong in the basics of trig and algebra, and you can actually do calculus. Anyway, thank you guys for your time.